Have you ever wondered what would happen if nature decided to throw out the rule book and just start experimenting with the most ridiculous combinations possible? Well, 250 million years ago, that's exactly what happened. Picture this. You're walking through an ancient forest, and you stumble across a creature that looks like someone mixed a horse with a sloth, gave it giant claws, and told it to eat salad. Or maybe you're swimming in a prehistoric river and come face to face with a whale that can literally walk out of the water and chase you on land. These aren't the products of some fevered imagination or late-night science fiction binge. These are real creatures that actually existed on our planet, and honestly, they make modern animals look boring by comparison. Today, we're diving into the fossil record to uncover some of the most mind-bending, physics-defying, and downright impossible creatures that somehow managed to thrive for millions of years. These are animals that challenge everything we think we know about how life is supposed to work. We're talking about prehistoric beasts so weird that when scientists first discovered their remains, they literally had no idea what they were looking at. But here's the thing that makes this even more incredible. These weren't just random evolutionary accidents that died out quickly. Many of these creatures were incredibly successful for millions of years. They dominated their environments, perfected hunting strategies that seem impossible, and developed adaptations that would make modern engineers jealous. Then something changed, and they vanished from the earth, leaving behind only fossilized evidence of their bizarre existence. By the end of this video, you'll understand why paleontologists sometimes question their career choices when they dig up certain bones. You'll see how evolution can create solutions that seem to violate the laws of physics. And you'll discover why being perfectly adapted to your environment might actually be the worst possible strategy for long-term survival. Let's start with something that sounds like it came straight out of a children's book about mixed-up animals. Imagine a whale, but instead of flippers, it has 4 fully functional legs. Not stubby little appendages, but actual weight-bearing limbs that could support its entire body on dry land. This wasn't some transitional creature that was still figuring out whether it wanted to live in the water or on land. This was a fully realized predator that had mastered both environments simultaneously. 49 million years ago, a creature called Ambulocetus was prowling the rivers of what is now Pakistan. The name literally means walking whale, which gives you a pretty good idea of what we're dealing with here. This thing was about 10 feet long, built like a crocodile that had been hit in the gym, and equipped with webbed feet for swimming and powerful legs for walking. But here's where it gets really interesting. It had already developed the sophisticated underwater hearing system that modern whales use today. See, whales don't hear underwater the same way we do. They use their jaw bones to channel sound vibrations directly to their inner ears, which allows them to echolocate and communicate across vast distances. Ambulocetus had figured out this exact same system while still maintaining perfectly functional legs for terrestrial movement. It was essentially running the ultimate hedge fund strategy, diversifying its investments across multiple environments so it could never be completely wiped out by changes in any single habitat. The hunting strategy was brilliant in its simplicity. Ambulocetus would position itself in shallow rivers, using its high-mounted eyes to scan the surface while its advanced hearing system monitored underwater activity. When something came to drink at the water's edge, it could launch itself forward, using its powerful tail for propulsion in the water and its legs for traction on land. Prey literally had nowhere to run because this predator could follow them anywhere. But evolution is never satisfied with good enough. The descendants of Ambulocetus eventually made a commitment to fully aquatic life, gradually losing their land mobility in exchange for better swimming performance. What we're looking at here is essentially the last moment in evolutionary history, when whales could still change their minds about the whole ocean thing. It's a snapshot of one of evolution's most dramatic career changes, captured in fossil form. Now, if a walking whale sounds impossible, wait until you hear about what happened when Earth decided to turn up the thermostat and snakes got access to unlimited growth potential. We're talking about the Paleocene epoch, roughly 60 million years ago, when this planet was experiencing some serious global warming. Temperatures in what is now Colombia were averaging around 93 degrees Fahrenheit year-round, which is hotter than most places get during summer today. In this hothouse world, something extraordinary happened in the snake department. Coal miners in Colombia discovered vertebrae that were the size of dinner plates. At first, they thought they'd found some kind of crocodile, which would have been exciting enough. But when paleontologists got their hands on these bones, they realized they were looking at something that redefined the concept of big snake. Titanoboa was 47 feet long and weighed over a ton. To put that in perspective, that's longer than a school bus and heavier than most cars. This wasn't just a really big snake. It was a biological impossibility that somehow managed to exist anyway. See, snakes are cold-blooded, which means they rely entirely on environmental heat to power their metabolism. The bigger you are as a cold-blooded animal, the more heat you need to keep your body functioning. Scientists realized that Titanoboa's size actually served as a biological thermometer. By calculating how much heat this massive snake would need to survive, they could work backwards to determine exactly how hot the Earth was during the Paleocene. It's like reverse engineering the climate from a single species, and the results were shocking. The planet was so hot that it could support snake species that would be physically impossible in today's cooler world. But here's the twist that nobody saw coming. This school bus-sized serpent wasn't out there crushing mammals or wrestling crocodiles. It was eating fish. The skull structure tells the whole story. Teeth that were perfect for grabbing slippery prey, but completely wrong for taking down large land animals. Titanoboa spent its days floating around in prehistoric rivers, casually consuming fish that were probably bigger than most snakes alive today. The reign of Titanoboa came to an end not because it wasn't successful, but because it was too successful at being huge. As the Earth's climate began to cool, this massive snake couldn't maintain its body temperature anymore. It had specialized so completely for a hot world that when temperatures dropped, it had nowhere to go. Meanwhile, mammals were just getting started with their whole make-your-own-body heat strategy, which turned out to be a pretty smart long-term investment. This pattern of extreme specialization leading to extinction is something you see over and over again in the fossil record. Evolution creates these incredible solutions to specific environmental challenges. But when those environments change, the most perfectly adapted creatures often become the first casualties. Speaking of aquatic nightmares, let's talk about what happens when you take a scorpion and scale it up to the size of a canoe. The Devonian period, roughly 400 million years ago, was apparently a really bad time to go for a swim in freshwater rivers. That's when Jaekelopterus was patrolling the waters of what is now Germany. And this thing was 8.5 feet of pure aquatic aggression. The first hint that something terrifying was lurking in Devonian rivers came in the form of a single claw, 18 inches long, just sitting in some German rocks. You have to imagine the paleontologist who found it probably stared at it for a while, then very carefully started looking for the rest of whatever it belonged to. When they finally pieced together the complete picture, they realized they weren't dealing with your average water bug. Jaekelopterus had compound eyes that could spot prey from across a river, hollow bones that made it lightweight despite its enormous size, and those massive claws weren't just for show. They had specialized teeth for puncturing and gripping, because back in the Devonian, fish were getting serious about armor. Thick plates, heavy scale, the whole defensive package. So Jaekelopterus did what any reasonable predator would do. It got bigger and stronger until it could crush whatever armor evolution threw at it. This led to one of the most epic evolutionary arms races in history. Fish developed better armor, so scorpions got bigger claws. Fish made thicker plates, so scorpions developed stronger muscles. This went on for millions of years, with each side constantly one-upping the other in an aquatic version of military escalation. The system worked perfectly until the late Devonian extinction event hit. Suddenly, all those heavily armored fish that Jaekelopterus had spent millions of years learning to crush just disappeared. When your entire business model is based on being the best at crushing expensive armor, losing your customer base is a serious problem. Jaekelopterus went extinct not because it wasn't good at its job, but because it was too good at its job. Meanwhile, smaller and more flexible predators survived the extinction just fine, which brings us to a crucial lesson about evolution. Getting too comfortable in your niche is basically signing your own death warrant. The fossil record is littered with creatures that became so specialized for their specific role that they couldn't adapt when rules changed. But at least these river monsters had the decency to stay in the water where they belonged. Our next creature, however, decided that the laws of physics were more like gentle suggestions. When paleontologists found the first Quetzalcoatlus wing bone in Texas back in the 1970s, they probably measured it, then measured it again, then quietly started wondering if they'd chosen the wrong career. We're talking about a 36-foot wingspan on a creature that stood as tall as a giraffe when it was on the ground. This was the largest thing that ever flew. and it managed to stay airborne right up until that asteroid decided to crash the Cretaceous party. Now, you might be wondering how something the size of a small airplane actually got off the ground. Did it need a runway? Did it have to jump off cliffs like some kind of prehistoric hang glider? Well, it turns out Quetzalcoatlus had figured out a much more elegant solution. It would crouch down on all fours with its wings folded back, then use pure arm strength to vault itself 8 feet straight up into the air. One explosive push, wings unfold, and suddenly you've got a flying giant soaring through the sky like it's no big deal. Once airborne, Quetzalcoatlus could ride thermals for hours without flapping, just cruising over the Cretaceous landscape and probably feeling pretty smug about the whole situation. For decades, scientists assumed this thing was a scavenger, basically a giant flying vulture that picked at dead dinosaurs. It made perfect sense given its size and the fact that there were plenty of dinosaur carcasses lying around. But then, researchers took a closer look at the physics involved, and the scavenger theory fell apart completely. Turns out Quetzalcoatlus spent most of its time on the ground, walking around on its folded wings and using its massive beak to hunt small animals. Picture this giraffe-tall nightmare just casually strolling across the plains, using its 6-foot-long skull to snatch up anything smaller than a person. Baby dinosaurs, lizards, early mammals, basically anything that couldn't outrun a walking death stork with a flight license. The whole setup was perfectly adapted for a world where being the size of a small aircraft was apparently a reasonable life strategy. Then the asteroid showed up, and suddenly being giant became a serious liability. Quetzalcoatlus had spent 68 million years casually defying physics. But even the most impressive flying abilities couldn't survive a global catastrophe that wiped out most large animals. But if you think a flying giant sounds intimidating, wait until you hear what happened when birds decided to take over the apex predator role after the dinosaurs disappeared. A teenager in Argentina was just casually looking around some rocks when they found a skull that was 28 inches long. Most high school kids find empty soda bottles when they're exploring. This kid discovered evidence that birds used to be absolutely terrifying. The skull belonged to Kelenken, and this thing was everything you never wanted to encounter. In a dark alley, 3 meters tall, built for running, and equipped with a beak that could probably crack a car windshield. This was South America during the Miocene epoch, when mammals were supposedly taking over the world everywhere else. Apparently, nobody told the South American birds about this memo. See, after the dinosaurs went extinct, South America got cut off from the rest of the world by geological changes. While mammals were establishing themselves as the dominant predators on other continents, South America decided to let the birds handle that whole apex predator situation, and they were really, really good at it. Kelenken had the biggest head of any bird that ever lived. That skull was larger than some dinosaur skulls, but this wasn't just for intimidation. The beak was engineered for delivering precise, devastating strikes, hooked at the end, reinforced throughout, and powered by massive neck muscles that could drive it down with the force of a hatchet. The hunting strategy was beautifully simple. Run down your prey using those powerful legs, then use the beak to deliver repeated brutal strikes until whatever you were chasing stopped moving. No grappling, no wrestling, just efficient, blunt force trauma applied with surgical precision. What makes this even more remarkable is that Kelenken was competing with actual mammalian predators. There were saber-toothed marsupials running around at the same time, giant bear dogs, all the usual suspects you'd expect to dominate an ecosystem. But the bird was winning. Terror birds like Kelenken dominated South American food chains for millions of years, while the rest of the world figured out that mammals were supposed to be in charge. This worked great until the continents reconnected and more modern predators moved south. Suddenly, terror birds were competing with cats and dogs and bears that had been perfecting their techniques for ages in a much more competitive environment. The birds had gotten really good at being the only large predators around, but they hadn't been preparing for an invasion of specialists who'd been dealing with serious competition for millions of years. Kelenken went extinct, not because it wasn't a perfect killing machine, but because being a perfect killing machine in isolation doesn't help when the entire rule book changes. It's like being the best player on a small-town basketball team and then getting drafted to the NBA. Same skills, completely different level of competition. Now, if terror birds represent evolution getting creative with existing body plans, our next creature shows what happens when evolution decides to just throw random features at a wall and see what sticks. Meet Chalicotherium, a mammal that looked like it was designed by a committee that couldn't agree on anything. Horse head, gorilla arms, giant sloth claws, and a strict vegetarian diet. This thing walked on its knuckles to protect its claws, then used those same claws to gently pluck leaves from trees. For decades, scientists couldn't figure out what they were looking at. They'd find horse-like teeth in one location, massive claws somewhere else, and the guy who first examined the claws thought he'd discovered a giant pangolin. Meanwhile, someone else was describing what looked like a horse with really weird teeth. Nobody connected the dots until much later when they realized they were all looking at the same impossibly contradictory animal. Chalicotherium had committed fully to being the most mixed-up creature possible. It was a hoofed mammal that didn't have hooves, a plant eater built like a predator, and a gentle giant that looked like it could tear you apart without breaking a sweat. Those massive claws that made everyone think it was some kind of super predator, they were actually precision tools for fine dining. The whole system worked like this. Chalicotherium would walk up to a tree, rear back on its hind legs, and use those enormous hooks to pull branches down to mouth level. It had basically turned itself into a living cherry picker, accessing food sources that other herbivores couldn't reach. The setup was so successful that it worked for about 15 million years, which is pretty impressive for something that looked like it was assembled from spare parts. But there was one small problem with Chalicotherium's lifestyle. Its entire feeding strategy depended on forests, lots of trees, lots of branches to pull down, lots of leaves to strip off. As long as the world stayed heavily forested, everything was perfect. Then the climate started cooling, grasslands began expanding, and forests started shrinking. Suddenly, Chalicotherium's highly specialized feeding strategy became a massive liability. You can't knuckle-walk your way to success in a world without trees. The last Chalicotheres hung on until relatively recently in geological terms, but they were living on borrowed time. When your entire body plan is built around one specific type of environment, environmental change becomes your worst enemy. This perfectly illustrates one of evolution's cruelest paradoxes. The most perfectly adapted creatures are often the most vulnerable to change. Jaekelopterus proves that sometimes evolution's most creative solutions end up being evolutionary dead ends. Being incredibly good at one thing is great until that one thing disappears. But at least Chalicotherium had the decency to use its teeth in a relatively normal way. Our next creature decided that having a reasonable number of teeth was for amateurs. Meet Nigersaurus, a dinosaur that was essentially a walking tooth factory. This thing could go through 500 teeth in its mouth at any given time, and it replaced them every 14 days. That means somewhere in this dinosaur's mouth, a new tooth was sprouting every 20 minutes for its entire life. The skull was basically a biological assembly line dedicated to tooth production. Rows and rows of replacement teeth were stacked up behind each working tooth, waiting their turn like customers at the world's most efficient dental clinic. The whole setup was so focused on cranking out teeth that the skull bones ended up paper thin. Some parts were less than 2 millimeters thick. You could probably see through them if you held them up to the light. This created a fascinating engineering problem. How do you build a head that's mostly empty space but still needs to support 500 teeth? Well, Nigersaurus solved this by basically giving up on everything else. No thick bones, no heavy jaw muscles, no powerful bite force. Just a wide, flat mouth, absolutely packed with teeth. Here's where it gets even weirder. Most long-necked dinosaurs use their necks to reach up high into trees, browsing on tall vegetation like living skyscrapers. Not Nigersaurus. This thing kept its head pointed straight down at the ground. Its inner ear was positioned so that looking down was the natural, comfortable position. You've got this 30-foot-long dinosaur that spent its entire life staring at the dirt, using its ridiculous tooth setup to essentially mow the lawn with its face. The strategy was perfect for its specific environment. The rivers of Cretaceous Africa were surrounded by soft, low-growing plants. Plenty of vegetation right at ground level, perfect for a dinosaur that had committed entirely to horizontal grazing. But the whole system was incredibly fragile. Those paper-thin skull bones meant that Nigersaurus couldn't handle any serious impact. It couldn't fight predators, couldn't crash through vegetation, couldn't even bite down very hard on its food. One wrong move and the whole delicate apparatus would collapse like a house of cards. The fossil record actually backs this up because complete Nigersaurus skulls are incredibly rare. They fell apart so easily that most of what we know comes from scattered pieces that had to be digitally reconstructed. The price of extreme specialization was extreme fragility. Speaking of creatures with attitude problems, let's talk about Pegomastax, a tiny dinosaur that sat in a South African museum drawer for 45 years because nobody had time to deal with whatever evolutionary nonsense they were looking at. When paleontologists finally got around to studying this thing in 2012, they discovered a plant-eating dinosaur about the size of a house cat that had vampire fangs and porcupine quills. Pegomastax had all the standard herbivore equipment, parrot beak for cropping vegetation, normal plant-grinding teeth in the back of its mouth, and then just randomly decided to throw in a pair of sharp canines right behind the beak. Apparently, regular herbivore gear wasn't dramatic enough. The fangs weren't for eating meat. They were for being petty. When another Pegomastax got too close to its food, it would deliver a quick nip to make its point. When a predator showed up, same thing. Just enough bite to communicate that it was having a bad day and you were about to make it worse. But the fangs were just the beginning. The whole body was covered in long, stiff bristles that stuck out in all directions, basically turning this tiny dinosaur into a walking punk rock album cover. The bristles made it look bigger and more intimidating than it actually was, which is pretty impressive when you're the size of a house cat. So you've got this spike-covered, fang-wielding vegetarian wandering around early Jurassic South Africa, probably scaring things twice its size just by existing. This is the definition of compensating for your size with pure attitude. What's really remarkable is that Pegomastax was actually pretty advanced for its time. Those self-sharpening back teeth were more sophisticated than what most other herbivores had. It could process tougher vegetation than its competition, and the fangs and quills were just bonus intimidation features. But tiny mysteries pale in comparison to 50 years of massive confusion. Picture this: 2 arms, 8 feet long each, sitting in museums with no body attached. That's all paleontology had to work with for 5 decades. Just these enormous limbs, clearly from something huge and bipedal, driving scientists completely insane. The arms were obviously from something that could probably tear a car in half, if it wanted to. So naturally, everyone assumed they belonged to some kind of super predator, the ultimate theropod, a Mongolian T-Rex killer, death incarnate with opposable thumbs. Artists drew these incredible monsters based on nothing but arm bones, giant carnivores with massive claws, stalking the late Cretaceous like movie monsters. Museums built entire exhibits around the idea that these arms belonged to the ultimate killing machine. The scientific community spent half a century imagining the most metal dinosaur possible. Then in 2014, scientists finally found the rest of the skeleton. 2 complete skeletons, actually, and it turned out everyone had been completely, hilariously wrong about everything. Deinocheirus had a duckbill, a camel hump, feathers on its tail, weighed 6 tons, and spent its time wading through rivers, eating fish and plants. Those terrifying claws that everyone was obsessed with, yeah, they were for digging up roots and pulling down branches. The whole scientific community had been fantasizing about some prehistoric nightmare, and it turned out to be a gentle giant that probably couldn't catch a sick turtle if its life depended on it. Even better, one of the new skeletons had fish scales in its stomach contents. So not only was this thing not a super predator, it was standing around in shallow water, catching fish with its bare hands like some kind of Mongolian fisherman. The discovery completely changed how paleontologists think about ostrich dinosaurs. Turns out the family was way more diverse than anyone realized. Some were fast runners, some were giant omnivores with duck bills and humps. This whole situation perfectly demonstrates how easy it is to let your imagination run wild when you only have fragments to work with. Scientists looked at those massive arms and immediately jumped to the most dramatic conclusion possible. It's like finding a steering wheel and assuming it belongs to a race car, then discovering it was actually from a school bus. But even Deinocheirus looks completely normal compared to what we're about to discuss. Russian swamps, 267 million years ago, before dinosaurs existed, before mammals were even a concept, something was already walking around with advanced mammalian features and a crown of elaborate horns. Estemmenosuchus had figured out glandular skin, complex social behavior, and sophisticated temperature regulation millions of years before mammals showed up to claim credit for these innovations. This wasn't just some primitive reptile stumbling around in the mud. Estemmenosuchus had actual glandular skin with specialized cells for temperature control and communication. Not scales, not basic reptile hide, but the kind of advanced skin system that we associate with modern mammals. The horns were equally impressive, 2 pairs of bony projections sticking out of its skull in different directions, creating this ornate crown that served no purpose except looking absolutely magnificent. The whole package worked perfectly for its swampy environment. Those horns stuck up above the waterline for communication and recognition between individuals. The glandular skin helped with the temperature control in fluctuating climates. The social behavior provided protection and resource sharing. It was essentially running a mammalian social system with reptilian hardware, 200 million years before mammals showed up. Here's what makes this truly mind-bending. Estemmenosuchus was a therapsid, which means it was on the evolutionary line that would eventually lead to mammals. It had already invented one of the most important mammalian features. Then that entire lineage went through multiple extinction events, survived the worst mass extinction in Earth's history, and eventually gave rise to the mammals we know today. So mammals didn't actually invent glandular skin. We just rediscovered it after our ancient relatives figured it out, lost it, and then spent 200 million years getting it back. Evolution apparently has a really long memory and doesn't mind repeating successful experiments when the conditions are right again. This brings us to a crucial point about how evolution actually works. It's not a straight line from simple to complex. Sometimes the most advanced features show up first, get shelved for hundreds of millions of years, then make a comeback when the timing's right. Evolution is like a mad scientist with unlimited time and resources, constantly running experiments and keeping detailed notes for future reference. The story of Estemmenosuchus also illustrates something profound about the nature of life on Earth. We tend to think of prehistoric creatures as primitive stepping stones leading up to modern animals, but that's not how it works at all. These ancient animals were just as sophisticated and well adapted for their environments as anything alive today. They weren't rough drafts or failed experiments. They were successful life forms that dominated their worlds for millions of years. What's really humbling is realizing that modern animals, including humans, are just the latest chapter in this ongoing story. We're not the culmination of evolution. We're just the current experiment. And like every other creature that's ever lived, our time on this planet is temporary. The fossil record is filled with species that were perfectly adapted to their environments, right up until those environments changed. That's the ultimate lesson of these impossible prehistoric creatures. Being perfectly adapted is actually a double-edged sword. It works great as long as conditions stay the same, but it becomes a liability when change inevitably comes. The most successful species over geological timescales are often the ones that maintain some flexibility, some ability to adapt when the rules change. Looking at these bizarre ancient animals also reminds us how creative evolution can be when given enough time and the right conditions. Every strange feature, every impossible combination of traits represents a solution to some environmental challenge. The walking whale solved the problem of hunting in both terrestrial and aquatic environments. The giant snake took advantage of an unusually warm climate to reach unprecedented size. The terror birds filled an ecological niche left vacant by extinct dinosaurs. Each of these creatures succeeded by finding a unique way to make a living in their particular corner of the ancient world. They pushed the boundaries of what seemed possible, defied our expectations of how animals should be built, and thrived for millions of years. The fact that they eventually went extinct doesn't diminish their achievements. In the grand scheme of geological time, even the most successful species are just brief experiments in the ongoing laboratory of evolution. What really gets me about these prehistoric misfits is how they force us to completely rethink what normal actually means. Take our next creature, which basically looked at the concept of being a reasonable size and said, you know what? I think I'll pass on that. We're talking about something so massive that when paleontologists first found its remains, they probably needed therapy afterwards. Meet Argentinosaurus, a dinosaur that weighed as much as 12 elephants and was longer than 3 school buses parked end to end. But here's the thing that really messes with your head. This wasn't some lumbering, slow-moving mountain of flesh. Recent studies suggest this thing could actually move at a decent clip when it needed to. Picture a creature the size of a small building casually strolling through Cretaceous Argentina at 15 miles per hour. The ground would have shaken like there was a constant earthquake wherever these things went. The engineering challenges alone should have made this impossible. How do you pump blood up a neck that's 40 feet long? How do you support a spine that's carrying the weight of multiple cars? How do you even breathe when your lungs are the size of hot air balloons? Argentinosaurus solved all these problems with solutions that seemed like they came from a science fiction novel. Multiple hearts working in sequence to maintain blood pressure. Hollow bones filled with air sacs to reduce weight while maintaining strength. A respiratory system so efficient it puts modern birds to shame. This thing was basically a biological skyscraper that could walk around and strip entire forests bare in a matter of days. But being the biggest thing on the planet comes with its own set of problems. You need massive amounts of food every single day. You can't hide from predators because you're literally the size of a building, and if you fall down, you're probably not getting back up. Argentinosaurus lived in a world where being gigantic was apparently a successful strategy, but it was also living on the edge of what physics would allow. Then there's the flip side of the size equation. While Argentinosaurus was busy being impossibly huge, other creatures were experimenting with being impossibly small in ways that make no sense whatsoever. Microraptor was a dinosaur about the size of a crow, but it had 4 wings. Not 2 wings like every other flying animal that's ever existed. 4 wings, 2 on its arms and 2 on its legs, like evolution couldn't decide which body part should handle the flying duties, so it just said, why not both? This tiny dinosaur was essentially a living biplane. The leg wings weren't just decorative either. They were fully functional flight surfaces with proper aerodynamic properties. Microraptor could glide between trees using all 4 wings in coordination, performing aerial maneuvers that would make modern fighter pilots jealous. It was like having a remote-controlled airplane that also happened to be alive and could hunt for its own food. The whole setup worked so well that Microraptor dominated the forest canopies of early Cretaceous China for millions of years. But apparently having 4 wings wasn't weird enough, because this thing also had iridescent black feathers that would have made it look like a flying rainbow in the right light. Evolution had created a tiny dinosaur that was part bird, part airplane, and part disco ball. What really gets me about Microraptor is how it challenges our assumptions about the evolution of flight. We always assumed that flight evolved once in a nice linear progression from flightless to flying. But here's evidence that evolution was running multiple flight experiments simultaneously. Some lineages went with the standard 2-wing setup. Others tried 4 wings. And who knows what other configurations got lost in the fossil record. Speaking of creatures that shouldn't have worked, let's talk about what happened when evolution decided to take the concept of armor plating and turn it up to 11. Ankylosaurus was basically a living tank that somehow managed to be an herbivore. This thing was covered in bony plates, spikes, and nodules from head to tail, with a massive club at the end that could shatter the leg bones of a Tyrannosaurus rex. But here's what really blows my mind about Ankylosaurus. It wasn't just heavily armored. It was intelligently armored. The placement of those bony plates followed engineering principles that humans didn't figure out until we'd started designing military vehicles. Thicker armor over vital organs, overlapping plates that could flex without creating weak points, and a low center of gravity that made it almost impossible to flip over. The tail club alone was a masterpiece of biological engineering. It wasn't just a random lump of bone stuck on the end of the tail. It was a precisely weighted weapon system with specialized vertebrae that could transfer the full power of the animal's body into a single devastating blow. Ankylosaurus could swing that club with enough force to break the ankle of a predator that weighed 3 times as much as it did. And this living fortress was a vegetarian. It spent its days peacefully munching on low-growing plants while wearing enough armor to stop a medieval army. The whole setup seemed like massive overkill until you remember what else was wandering around the late Cretaceous. When you're sharing your neighborhood with Tyrannosaurus rex and other giant predators, maybe being a walking tank isn't such a bad strategy after all. But even Ankylosaurus looks reasonable compared to our next creature, which took the concept of weird feeding strategies and pushed it into territory that seems like it came from a fever dream. Therizinosaurus was a dinosaur that stood 15 feet tall, had claws that were 3 feet long, and used them exclusively for gathering plants. It was like evolution decided to build the ultimate predator, and then at the last minute said, actually, let's make it a vegetarian instead. Those massive claws that should have been tearing apart prey were instead being used to delicately strip leaves from branches. Therizinosaurus had essentially turned itself into a living hedge trimmer, using weapons-grade claws for gardening. The whole animal was built like a nightmare, but it spent its days peacefully harvesting vegetation like some kind of prehistoric farmer. The really mind-bending part is how successful this strategy was. Therizinosaurus wasn't some evolutionary dead end that got eliminated quickly. It thrived for millions of years, growing to enormous sizes and diversifying into multiple species. Apparently, being a giant vegetarian with claws the size of baseball bats was a perfectly reasonable way to make a living in the Cretaceous world. This brings us to one of the most important lessons about prehistoric life. Our assumptions about what makes sense are often completely wrong. We look at massive claws and immediately think predator. We see armor plating and assume the animal was under constant attack. We find tiny creatures with 4 wings and wonder how they could possibly work. But these animals didn't care about our expectations. They found ways to thrive that challenge everything we think we know about how life is supposed to work. The fossil record is full of these apparent contradictions. Gentle giants that looked like monsters, tiny creatures that dominated their environments through sheer attitude, predators that gave up hunting to become gardeners. Each of these animals represents a unique solution to the challenges of survival, and many of them worked for far longer than any species alive today has existed. What's really humbling is realizing how much we still don't know. Every year, paleontologists discover new species that force us to rewrite our understanding of prehistoric life. Creatures that seem impossible but somehow manage to exist for millions of years. Animals that developed solutions to problems we didn't even know existed. The more we learn about these ancient animals, the more we realize that modern life is just a tiny sample of what's possible. Evolution has been running experiments for over 3 billion years, and most of the results have been lost to time. We're only seeing the tiniest fraction of the incredible diversity that once existed on this planet. Take Carnotaurus, for example. This was a predatory dinosaur that decided horns were a good look for a meat eater. Not small decorative horns, but actual bull-like horns sticking out above its eyes. It also had tiny vestigial arms that were even more useless than T-Rex arms, which is saying something, but what really set Carnotaurus apart was its speed. This thing was built for running. Long, powerful legs, a lightweight build, and a body designed for pursuit hunting. Carnotaurus could probably run faster than a modern racehorse while weighing as much as an elephant. It was like a horned missile with teeth, capable of chasing down prey across the open plains of Cretaceous Argentina. The combination seems absurd. Horns for headbutting, tiny arms that couldn't grab anything, and legs built for marathon running. It's like evolution threw a bunch of random features together and somehow created a successful predator. But Carnotaurus worked, and it worked well enough to survive for millions of years in an ecosystem filled with other massive predators. Then there's Parasaurolophus, a duck-billed dinosaur that decided its head needed to double as a musical instrument. The long, curved crest wasn't just for show. It was a hollow tube that worked like a natural trumpet, allowing these animals to communicate across vast distances with haunting, melodic calls. Entire herds could coordinate their movements using complex musical signals that would have made the Cretaceous landscape sound like a prehistoric orchestra. Different species of Parasaurolophus had different crest shapes, which means they probably had different voices too. Some would have produced deep, booming calls like a foghorn. Others might have sounded more like a flute or a clarinet. The diversity of sounds would have been incredible, with different species essentially speaking different musical languages. What gets me about Parasaurolophus is how sophisticated the whole system was. This wasn't just random noise-making. These animals had developed complex acoustic communication millions of years before humans figured out how to make music. They were using their heads as precision instruments, fine-tuned for specific frequencies and ranges. The really wild part is that we can actually recreate the sounds these animals made. Scientists have built working models of Parasaurolophus crests and recorded the calls they would have produced. You can literally listen to the voice of a dinosaur that died out 75 million years ago. It's like having a recording from the deep past, a glimpse into a world where giant musical herbivores filled the air with haunting melodies. But perhaps the most mind-bending creature of all is one that challenges our basic understanding of what an animal should look like. Hallucigenia was discovered in the famous Burgess Shale Formation, and when the scientists first tried to reconstruct it, they literally put it together upside down and backwards. That's how weird this thing was. Picture a creature that looks like it was designed by someone who had never seen an animal before. 7 pairs of spiny legs on the bottom, 7 pairs of defensive spines on the top, a head that's almost impossible to distinguish from the tail, and a feeding apparatus that seems to come from another planet entirely. Hallucigenia moved through the ancient oceans like a living nightmare, using its bizarre anatomy to process food in ways that still aren't completely understood. The really unsettling thing about hallucigenia is that it represents a completely different approach to being an animal. Modern creatures all follow certain basic body plans that we take for granted. Bilateral symmetry, distinct head and tail ends, organized organ systems. But hallucigenia suggests that in the early days of complex life, evolution was experimenting with body plans that seem almost alien to us now. This creature existed over 500 million years ago, during a time period called the Cambrian explosion, when life was trying out every possible variation on the theme of being a complex organism. Most of these experimental body plans didn't survive, but for a few million years, the oceans were filled with creatures that would look at home in a science fiction movie. Hallucigenia reminds us that the familiar possible solution to the problem of being alive animals we see today are just one. Evolution could have gone in completely different directions, creating worlds filled with creatures so strange that we can barely comprehend them. The fact that it didn't doesn't make these alternative possibilities any less real or fascinating. What all these creatures have in common is that they push the boundaries of what we think is possible. They challenge our assumptions about how animals should be built, how they should behave, and how they should interact with their environments. Each one represents a unique experiment in the laboratory of evolution, a test of what works and what doesn't in the endless struggle for survival. The fact that most of these creatures are extinct doesn't diminish their achievements. They found ways to thrive in their respective time periods, often for millions of years. They developed solutions to environmental challenges that we're only beginning to understand. They created ecological relationships and evolutionary strategies that have never been repeated. Looking at these impossible creatures also gives us perspective on our own place in the history of life. Humans have been around for a geological blink of an eye compared to some of these ancient species. We're just the latest experiment in evolution's ongoing research project, and like every other species that's ever lived, our time here is temporary. But that temporariness doesn't make our existence any less remarkable. Just like Argentinosaurus and Microraptor and Hallucigenia, we represent a unique solution to the challenge of being alive. We've developed our own set of impossible-seeming abilities: complex language, abstract thought, the ability to understand and manipulate our environment in ways no other species has ever achieved. The prehistoric creatures we've been discussing succeeded by finding their own unique ways to exploit the resources and opportunities available in their environments. They didn't try to be like other animals. They developed their own approaches to the fundamental problems of survival. In that sense, they offer us a lesson about the importance of innovation and adaptation in an ever-changing world. As we continue to uncover more fossils and piece together the story of life on Earth, we're constantly reminded that the history of our planet is far stranger and more wonderful than we ever imagined. Every new discovery adds another chapter to the incredible story of evolution's creativity, another example of life finding a way to thrive under the most unlikely circumstances. These creatures shouldn't have existed, but they did. They shouldn't have worked, but they thrived. They represent billions of years of evolution's greatest hits, a collection of life's most creative and unlikely success stories. And the best part is, we're still discovering new ones all the time, still finding fossils that force us to expand our understanding of what's possible in the grand experiment we call life. But speaking of creatures that make you question everything you thought you knew about biology, let's dive into something that spent half a century driving paleontologists absolutely insane. Imagine walking into a museum storage room and seeing two massive arms just sitting there, 8 feet long each. No body, no skull, no explanation. Just these enormous limbs with claws that could probably slice through a tree trunk like butter. That's exactly what happened with Deinocheirus. For 50 years, scientists had nothing but these gigantic arms to work with, and naturally, everyone's imagination went completely wild. The arms were clearly from something bipedal, something huge, something that could probably bench press a truck if it wanted to. So the scientific community did what any reasonable group of people would do when faced with incomplete evidence. They let their imaginations run absolutely wild. Artists started drawing these incredible monsters based on nothing but arm bones. Picture the most terrifying predator you can imagine, then make it twice as scary and give it claws the size of baseball bats. Museums built entire exhibits around the idea that these arms belonged to some kind of super predator that made Tyrannosaurus rex look like a house cat. The whole paleontology community spent decades fantasizing about what might be the ultimate killing machine. Then in 2014, scientists finally found complete skeletons. 2 of them, actually. And it turned out everyone had been spectacularly, hilariously wrong about everything. Deinocheirus wasn't a nightmare predator at all. It had a duck bill, a camel-like hump on its back, feathers decorating its tail, and it spent most of its time wading around in rivers, catching fish with its bare hands like some kind of prehistoric fisherman. Those terrifying claws that everyone was obsessing over, they were gardening tools. This gentle giant used them to dig up aquatic plants and pull down tree branches for snacking. The most metal-looking dinosaur arms in history belonged to what was essentially a really big, really weird herbivore that couldn't hurt a fly if it tried. One of the skeletons even had fish scales preserved in its stomach contents, which just adds insult to injury. Not only was this thing not a super predator, it was standing around in shallow water having a peaceful lunch while everyone spent 50 years imagining it as the ultimate apex predator. It's like finding a chainsaw in someone's garage and spending decades convinced they're a serial killer, only to discover they're actually a professional tree sculptor. The whole Deinocheirus situation perfectly illustrates how dangerous it can be to jump to conclusions based on incomplete evidence. Scientists looked at those massive arms and immediately assumed they belonged to something terrifying, because that's what our brains are wired to do. Big claws equal dangerous predator, except sometimes big claws equal really efficient salad tongs. But even the most embarrassing paleontological mistake pales in comparison to what evolution came up with next. We need to talk about a creature that had figured out mammalian biology before mammals even existed. Picture this. You're walking through a Russian swamp 267 million years ago, back when the continents were still figuring out where they wanted to be. And you encounter something that looks like it stepped out of a time machine. Estemmenosuchus was rocking advanced mammalian features when the ancestors of actual mammals were still basic reptiles, trying to figure out how temperature regulation worked. This thing had glandular skin, the kind of sophisticated temperature control system that we associate with modern mammals. Except it evolved this tech hundreds of millions of years before mammals showed up to take credit for the innovation. But the skin was just the beginning. Estemmenosuchus also had this absolutely ridiculous crown of horns sticking out of its skull in all directions. Not practical defensive horns or intimidating predator horns, decorative horns that served no purpose except making this swamp-dwelling creature look like prehistoric royalty. It was basically wearing a bone tiara while pioneering mammalian biology. The whole package worked perfectly for its environment. Those horns stuck up above the waterline when it was wading through swamps, making it easy for individuals to recognize each other. The advanced skin helped with temperature control in the fluctuating climate, and the social behavior that came with this setup provided protection and resource sharing that would make modern mammals jealous. Here's what really messes with your head about Estemmenosuchus. It was a therapsid, which means it was actually on the evolutionary line that would eventually lead to mammals. So this creature had already invented one of the most important mammalian innovations. Then that entire lineage went through multiple extinction events, survived the worst mass extinction in Earth's history, and eventually gave rise to the mammals we know today. Which means mammals didn't actually invent glandular skin. We just rediscovered it after our ancient relatives figured it out, lost it during various catastrophes, and then spent 200 million years slowly working their way back to the same solution. Evolution apparently keeps really detailed notes and doesn't mind reusing good ideas when the timing is right. This whole situation reveals something profound about how evolution actually works. It's not a straight line from primitive to advanced. Sometimes the most sophisticated features show up first, get temporarily shelved due to changing circumstances, then make a comeback millions of years later when conditions are favorable again. Evolution is like a mad scientist with unlimited time and a really good filing system. Speaking of creatures that challenge everything we think we know about prehistoric life, let's talk about what happened when dinosaurs decided to experiment with interior decorating. Borealopelta was an armored dinosaur that took camouflage to a level that would make modern military engineers weep with envy. This thing wasn't just heavily armored, it was artistically armored with a color scheme so sophisticated that it preserved in the fossil record for 110 million years. When scientists first analyzed the pigment patterns on this remarkably preserved specimen, they discovered something that completely changed how we think about armored dinosaurs. Borealopelta had countershading, the same camouflage technique used by modern animals like deer and sharks. Dark colors on top, light colors on the bottom, creating an optical illusion that makes the animal blend into its surroundings. But here's what really blows your mind about this discovery. Borealopelta was basically a walking tank covered in spikes and armor plating, weighing as much as a rhinoceros. The fact that it needed camouflage at all tells us something terrifying about what else was wandering around the early Cretaceous. When a living fortress needs to hide from predators, you know the neighborhood was seriously dangerous. The preservation of the color patterns also gives us our first real glimpse into what these ancient worlds actually looked like. For the first time, we can say with confidence what color a specific dinosaur was. And it turns out they were way more sophisticated about visual presentation than anyone expected. This wasn't just random pigmentation. It was a carefully evolved system of optical deception. But sophisticated camouflage seems almost reasonable compared to our next creature, which decided that the normal rules of being a mammal were more like suggestions. Meet Casterocauda, a beaver-like animal that lived 164 million years ago, and basically said, "Hold my prehistoric beer," to every assumption we had about early mammalian evolution. This thing had a beaver tail, otter-like limbs for swimming, fur for insulation, and teeth designed for eating fish. It was essentially a fully aquatic mammal living alongside the dinosaurs, which is like finding out your great-great-great-grandmother was running a tech startup in the 1800s. The timeline just doesn't make sense until you realize that evolution has been running way more experiments than we ever imagined. Casterocauda wasn't just paddling around in shallow ponds either. This was a sophisticated aquatic predator with all the gear necessary for an underwater lifestyle. Webbed feet, dense fur that trapped air for buoyancy control, and sensory whiskers for detecting prey in murky water. It had figured out the complete aquatic mammal package 100 million years before whales decided to take the plunge. The really mind-bending part is that this represents a completely independent evolution of aquatic adaptations in mammals. Casterocauda developed its underwater lifestyle separately from every other aquatic mammal we know about. Evolution essentially solved the same problem multiple times using different approaches, like a mathematician working out the same equation using completely different methods. What's really humbling about discoveries like this is how they force us to completely rethink our assumptions about prehistoric ecosystems. We tend to imagine the age of dinosaurs as a time when mammals were tiny, primitive creatures hiding in the shadows. But here's evidence that mammals were already experimenting with complex lifestyles and sophisticated adaptations, while dinosaurs were still figuring out their own evolutionary strategies. This brings us to one of the most important lessons about studying prehistoric life. Every new discovery has the potential to completely rewrite what we thought we knew. The fossil record is like a massive jigsaw puzzle where we're constantly finding pieces that don't fit our current picture, forcing us to step back and reconsider the entire image. Take Therizinosaurus, for example. When paleontologists first found the claws of this creature, they were convinced they'd discovered the ultimate predator. 3-foot-long claws that looked like they could slice through armor plating without breaking a sweat. Everyone imagined some kind of super carnivore that made Tyrannosaurus rex look like a gentle lamb. Then they found the rest of the skeleton and discovered that this nightmare-looking creature was actually a vegetarian. Those massive claws that should have been tearing apart prey were instead being used to delicately strip leaves from trees. Therizinosaurus had essentially turned weapons-grade hardware into gardening equipment, like using a sword to trim your hedges. The whole animal was built like it should have been terrorizing other dinosaurs. but it spent its days peacefully harvesting vegetation. 15 feet tall, covered in feathers, armed with claws the size of baseball bats, and using all of that intimidating equipment to practice prehistoric horticulture. It's like evolution decided to build the ultimate warrior, and then at the last minute said, actually, let's make it a pacifist instead. But here's what really gets me about Therizinosaurus. This strategy was incredibly successful. These giant vegetarian monsters thrived for millions of years, growing to enormous sizes and diversifying into multiple species across Asia and North America. Apparently, being a gigantic feathered garden enthusiast with claws that could double as farming implements was a perfectly reasonable way to make a living in the Cretaceous world. This pattern keeps showing up with the fossil record. Creatures that seem designed for one lifestyle but actually lived completely differently. Predator-looking herbivores, tiny creatures that dominated their environments, giants that were gentle as lambs. It's like evolution enjoys confusing future paleontologists by creating animals that defy every expectation we have about how biology should work. And speaking of creatures that shouldn't work but somehow did, we need to discuss what happened when evolution decided that having a reasonable number of teeth was for amateurs. Nigersaurus was essentially a living tooth factory that could go through 500 teeth at any given time, replacing them every 2 weeks like some kind of biological dental assembly line. The skull was basically engineered around tooth production. Rows and rows of replacement teeth were stacked up behind each working tooth, waiting their turn like customers at the world's most efficient orthodontist office. The whole setup was so focused on cranking out teeth that the skull bones ended up paper thin. Some parts were less than 2 millimeters thick, so delicate you could probably see through them. This created a fascinating engineering challenge. How do you build a head that's mostly empty space but still needs to support 500 teeth? Nigersaurus solved this by giving up on everything else. No thick bones, no powerful jaw muscles, no crushing bite force. Just a wide, flat mouth absolutely packed with teeth and powered by the biological equivalent of a low-speed lawnmower engine. But here's where it gets really weird. Instead of using its long neck to reach up into trees like other sauropod dinosaurs, Nigersaurus kept its head pointed straight down at the ground. Its inner ear was positioned so that looking down was the natural, comfortable position. This 30-foot-long dinosaur spent its entire life staring at the dirt, essentially mowing the lawn with its face. The strategy was perfect for its specific environment. The rivers of Cretaceous Africa were surrounded by soft, low-growing plants. Plenty of ground-level vegetation perfect for a dinosaur that had committed entirely to horizontal grazing. But the whole system was incredibly fragile. Those paper-thin skull bones meant that one wrong move could collapse the entire delicate apparatus. The fossil record backs this up because complete Nigersaurus skulls are incredibly rare. They fell apart so easily that most of what we know comes from scattered pieces that had to be digitally reconstructed. It's like trying to study a house of cards that's been sitting in a tornado for 100 million years. What Nigersaurus represents is evolution pushing specialization to its absolute limits. This creature had optimized itself so completely for one specific feeding strategy that it became incredibly vulnerable to any kind of disruption. The price of being perfectly adapted was extreme fragility, which is a lesson that applies to way more than just dinosaurs. But even the most specialized prehistoric creatures pale in comparison to what we're about to discuss next. Sometimes evolution creates something so bizarre that when scientists first discover it, they literally don't know which end is the head. That's exactly what happened with hallucigenia, a creature so weird that paleontologists initially reconstructed it upside down and backwards. Picture an animal that looks like it was designed by someone who had never seen a living creature before. 7 pairs of spiny legs on the bottom, 7 pairs of defensive spines on the top, a head that's almost impossible to distinguish from the tail, and a feeding apparatus that seems to belong on an alien planet. Hallucigenia crawled across the seafloor of ancient oceans like a living nightmare, processing food in ways that still aren't completely understood. The really unsettling thing about hallucigenia is that it represents a completely different approach to being an animal. Modern creatures all follow certain basic rules that we take for granted. Clear front and back ends, organized body symmetry, predictable organ placement. But hallucigenia suggests that in the early days of complex life, evolution was experimenting with body plans that would seem almost alien to us today. This creature existed over 500 million years ago during the Cambrian explosion, when life was essentially throwing everything at the wall to see what would stick. Most of these experimental body plans didn't survive, but for a few million years, the oceans were filled with creatures that would look right at home in the most creative science fiction movie you could imagine. What hallucigenia reminds us is that the familiar animals we see today represent just one possible solution to the problem of being alive. Evolution could have gone in completely different directions, creating worlds filled with creatures so strange that we can barely wrap our heads around them. The fact that it didn't doesn't make these alternative possibilities any less fascinating or real. Looking at all these impossible creatures together, you start to see patterns in how evolution operates. It's not following some predetermined plan or working toward specific goals. Instead, it's constantly running experiments, testing new combinations of features, and keeping detailed notes about what works and what doesn't in different environments and time periods. So there you have it, a collection of creatures that prove evolution has absolutely zero interest in playing by any rules whatsoever. From walking whales to musical dinosaurs to creatures so weird that scientists literally assembled them backwards, these animals remind us that life on Earth has been far stranger and more creative than we ever dared to imagine. The next time you think modern animals are impressive, just remember that we're living in the aftermath of billions of years of evolutionary experimentation that produced results so bizarre they shouldn't have been possible.